Hi guys, welcome to Learning Electronics Repair. This is the EVGA 1000 GQ 1000 watt ATX power supply that I picked up at the car boot sale a few weeks ago. Paid €10 for it. Yes, I've unsoldered this. It has rather a lot of corrosion in this. It looks like water's got into it. So in the previous video I had a look around this. There is some corrosion in this part of the circuit, so this is the high voltage side of it. There are 3 heat sinks, so I think we can say this is PFC. This is the switching transistors that drive the power supply. This one here will be for the standby. Okay, and then this is the low voltage side, so diodes, regulators and such like, and then this is the chip which monitors the power supply. So this monitors the output rails and checks for over voltage, under voltage, over current and such like, and then controls the pulse width modulation, which will be this chip. I'm thinking says 6600 on it. I don't have a data sheet for that, by the way. And you can see, generally speaking, there is quite a bit of corrosion on this. Most of the worst of that is on this side, so the low voltage side. Okay, this is where I unsoldered the little control PCB. So we see corrosion down here as well. The other side of the board, not so bad, other than I actually lost a pad there while I was desoldering this thing. Okay, so the question in the last video was whether this thing is even repairable, and we can say that the standby works. So we have 5-volt standby, nothing else comes up, it doesn't start. The fuse is intact, and I don't see any short circuits in this area, the high voltage side, and there's not so much corrosion over there either. There's quite a bit down here though, you can see in these tracks. The upshot of all this is that this is the little controller board. This is badly corroded, you can see that. But quite a few of you guys, so this is going to be your fault if it all goes horribly wrong, I'll just state now, yeah, said see if you can repair it. You were interested to see whether this could be repaired. I think we all agreed that we wouldn't say just how reliable it would be if it was repaired, but it was interesting to see if it could be repaired. So I had to order some of these chips. I didn't have any, I have some now. Let's see if we can actually fix this. So the first thing I'm going to do is remove this chip and then try to give this board more of a clean. We can see some corroded traces here. I did check with the multimeter, they seem to be intact. We see more corrosion around here. So let's get this chip off and then let's see how clean we can actually get this thing. On the other side of the board we also had this chip, which I couldn't identify, but some people actually did identify this in the comments on the previous video. This is a hole blown in it, so that needs to be changed as well. Okay, let's start by unsoldering this chip. So I'll add some flux. Okay. And then I'm going to add some leaded solder. I find the chunky BC3 tip is best for this sort of thing. Okay. But I'm going to use the vacuum desoldering tool to unsolder the chip. If that doesn't work easily, I'm going to actually cut all the pins off this chip and remove the pins individually. I'm certainly not going to be replacing this one back on the board. I have new ones, so I don't really care much about the chip. Let's see if this wants to unsolder. First one did. Of course, you'll always find some do and some don't. And you may also find that they look like they've unsoldered, but they haven't. Just keep this thing clear before it clogs. Okay, I'm not sure that third one unsoldered. Looks a bit better. Let's see. So I'll just check to make sure the pins are actually unsoldered. That one isn't. That one isn't. So I have a couple on that side that weren't really questionable. That feels a bit tight. Okay, so I have this one which doesn't feel like it's unsoldered properly. Feels better. Another one. Still doesn't feel brilliant, but I think it's clear. Yeah, that one's moving anyway. Okay. Let's see. Yeah, so I'm not putting any pressure. That came out right. And there we can see what's underneath it. Now the other chip. This one, I could try using the hot tweezers, but there's a lot of components very close to this one. Again, I obviously don't want the chip. It's got a hole blown in it. I may be able to cut the legs off this, but to be quite honest, sometimes that just rips the pad off. We can give it a go. Let's see if these will come off cleanly. So we'll get the blade very close to the chip. Did that cut through? Try a better blade. This one's a bit worn, yeah. Let's try again. Is this one better? Okay, that technique is not going to work. Right. Bridging the pins actually helps. Let's try the hot tweezers, if I can get in the correct angle to do it. Let's see. So I have this quite chunky thing here in the way. Try the other direction. this might just work, guys. We can get towards that back pin, that's the problem on that side. The other side is pretty good. Can we get into this one? Almost. You see why that blob of solder on the other side helps, yeah? It feels like it's glued, actually. It's off. And it was glued. Yeah, you can see where it was glued down. So actually you would have struggled with hot air there, to be quite honest. I think that was the best way. Okay, so we've removed that. Let's clean this up and then let's have a quick look around here at any semiconductor junctions, see if we can spot any other obvious problems. Okay, so I've cleaned all that up with the fiberglass pen. Sorry, I thought I was recording. I wasn't. Yeah. So I'm now going to put this in the sink with soap and water. I used isopropyl alcohol with the pen, and I had this on a piece of kitchen roll because this is fiberglass. You get little shards of fiberglass on your bench, and you may not be able to see them, but you feel it when they stick into your skin. They sting. They're not very nice. Okay, so it's not a good thing to get on your desk. Even like that little bit I just did, you want to just give the deck a good clean. So I'll put this in the sink, soap and water, and let's see how it comes out. And here is our board. We still have corrosion around here. I think probably the best thing I can do with these is just go over with a soldering iron, actually. We can see these are glued down as well, actually. So yeah, go around with a soldering iron. Here's a via. Another one. Nothing on, that's just grubby solder basically. Okay. Yeah, so I think I'll go around all these joints with solder, flux, then clean it up again. Yeah, a little bit more on here. Let's have a look. Same here with these vias. So he's definitely come cleaner, but wants more work, to be honest. Yeah. Other side. I'd say this looks pretty good now. Okay, so flux, solder, let's see what we can do. I'll use a finer tip for this, and I'll use some of this 0.2mm solder. Don't want to get too much of it on the board. Want to be careful I don't unsolder these components. I really don't want to do that. I just want to add some fresh solder. So not going to put much pressure against the component. I think if I warm it a bit with hot air, it's going to help. Just give the area a warm. Not too much. Okay, let's go again. It's possible the bigger, chunkier tip might help. We'll find out in a minute. Yeah, it's hard to get into that dirty solder. Probably better just try hold these down with tweezers. I don't want anything going wandering off. Okay. You can see it's not easy to melt that contaminated solder. Obviously let the thing cool down before you try to do the other side. Okay. Yeah, this is better. Okay, this honestly doesn't look so bad. It's corroded, but doesn't look so bad. These Well, they're all clearly soldered on this side, corroded, but I don't see any cracked or dry joints really. Okay. Let's clean this up and see how this came out. So again, isopropyl alcohol. Okay, so clearly still some corrosion on the board, but definitely better than it was, especially on these resistors. Around here, yeah, better. I think that's actually clean. Okay. All of the wires look okay on the other side. Hard to say. I mean, you would have to literally go with a meter and trace each one, but obviously you need to trace from one side to the other side, which isn't particularly easy. I'm going to go with the likelihood that they are probably okay. Let's look for the semiconductor junctions on the board. So we have possibly a couple of transistors here. This is the black lead. Just reads a voltage, not a semiconductor junction. Reads open, go the other way. Junction not. Okay. I was thinking that looked like it was bad, but it's just the light on it. Look at it, tilt it upwards. It's fine. Yeah, it looked like a broken connection there, but it's a shadow. HD suggests it's a diode in actual fact. Have a connection to it. Reads open. Reads open. That's if it is a diode. HD. You think it possibly is a diode. HU you think is a transistor. No, HU is probably an IC. So that might even be something like a TL431 or something. I don't know the code. But it doesn't read like a transistor, but then it's not marked like a transistor. This one, HQ, so that suggests it probably is a transistor or MOSFET. Yeah, junction. Junction, okay. Looks alright. Not sure about this diode, if it is a diode. I mean, it could be something like a transient suppressor or something else. It's right next to this socket, which is the fan, in actual fact. Okay, some more transistors on the other side. We'll come to them in a minute. Maybe bad, maybe not. Can't really say. But I don't know what it is. That's the problem there. What I can say is it checks the connections with a meter at least, so no problem with the connection. Okay. Another one is HD. Wonder what that one reads like. Let's have a look. Well, that reads like a diode. Yeah, that is a diode, HD. So based on that, and there's a white stripe on it here, and this has a white stripe here, the polarity is the other way round. Okay. Like so. And this one reads bad. That reads bad to me. Reads like a silicon rectifier. It doesn't read like a Zener. Otherwise it would be the higher voltage, probably about 0.7. Although I have seen some Zeners that don't, to be honest. So I think we have a bad diode there. What's this one? HQ, looks like a transistor. Doesn't read like an MPN. Well, not to there, it doesn't. Oh, it does. Bad connection. Reads like an NPN transistor. I expect this might have a reading in this direction. Doesn't actually, but you can never quite say. Collector emitter depending what's in the circuit. So faulty diode. Is that connected on the fan? Where does that go to? Yeah, it goes to the fan. It's a possibly. Oh, that's what's wrong with it now. Do you see what's wrong with it? That's why it's not reading. So this track was actually corroded through. This is where I was trying to solder and said I was struggling to do so. Does the diode look okay? Other way. No, it doesn't read good, that. I'm going to take a guess and say that that is probably something to do with the back EMF from the fan motor. It is an inductor after all. We can see it solders to there. So I can probably just connect something like a 1M4007 or something where that is, okay? So that we need to fix. Although I can only imagine it'll just stop the fan from working. And this transistor or chip HU is probably involved in the fan. Other side, what do we have? Diode. Reads like some sort of fast switching diode. 0.46. Okay. Transistor. Looks okay for a transistor. If it's an NPN, which it looked like, then you would think this was positive when it's actually in operation, so it should read open, which it does. That's a Zener, HZ1, which tells me the other one is definitely not a Zener. So I'm feeling very confident of just sticking the diode in there. Looks like we go this way round. Yeah, diode. Zen is going to read about 0.7. 0.67. See, it reads higher. That usually indicates a Zen. Yeah, silicon rectifier. What's this thing? Another diode. That reads like a Schottky. 3.17 reads like a Schottky diode. Transistor. Reads open that way. Open that way. Let's go the other way. This is the PNP transistor. Looks like it. So with the positive to the emitter, they should read open, you would think. Well, it's a fairly high reading open. PNP transistor. What else do we have? Another Zener. So I'm expecting it'll read about 0.7. Yeah, you see? Zener. That's how you recognise things, guys. A bit of experience involved in this, obviously. Looks like a big diode. Reads like a Schottky. This is one of these HD again. 0.53, 0.54. Yeah, 0.53 again. All resistors, capacitors. And that's about it on that side of the board. So the only issue I can see, other than the two ICs, is this diode reads open circuit. So let's get that off my board. Bit of corroded track there. You can see the diode symbol now. Can we tin that? Looks like it, yeah. Not very good, but probably sinking a lot of heat actually, that's why it's doing that to the solder. Bit better. Right. This says fan switch actually, and this says fan, so a switch maybe? Okay, I didn't really notice. There's probably one on the back of the power supply or something, or somewhere, or you can connect a switch that allows you to put the fan into quiet mode or something like that. So yeah, we'll stick a 1M4007 in here. And I'm not short of space here, so I think a through-hole one will be fine, actually. Okay, so this is where it solders under here. And we're reading 0.51. Okay, and that actually comes from here. 0.51. Okay, so we have a good connection there now. And as I say, there's plenty of room in this, so that really isn't a problem, I don't think. A little bit messy maybe, but let's see if this thing will actually work. It doesn't look too bad at all once I've cleaned the flux off. Now let's replace the chips. So we have WT7527S, which is a replacement for that one. This is a T. I had a good look and could not honestly see any difference between the S and the T. I tried to research what that was, didn't get me anywhere, but I couldn't find any T, I could only find S, so that's what's going in there. Okay, for good or for bad, we may find out. And this little thing with a hole in it, thank you to a few different subscribers, they found the correct one. So this is it, 54231, or rather TPS 54231. I was just thinking actually, I was just bending this against the side of the desk. This is how I straighten pins. I kind of like just push on them against the side of the desk. And I remember when I was at ICL, we had something called DIL-IC rollers, dual line IC rollers. It was like a metal square section thing on like a plate, and there was two little wheels with a slight gap, and you kind of like slid the chip along the metal thing between the two little rollers, and it straightened the pins. And I've just thought actually, I've never seen one of them since I worked at ICL. Oh, there's something you can get. I've never looked. DIL-IC roller, yeah. Or were they something that ICL just had made? I really don't know that. Guys, down there. So now we come to the question of the main board. This is all low voltage circuitry, as I mentioned before. So although there's quite a bit of corrosion around there, there's no high voltages, no more than 12 volts. This could probably do with a bit of a clean, and I still have the problem whereby I have a pad off on the other side, I think. Yeah, this one. From what I can see, that doesn't actually connect to anything. You may think you are seeing a track going here, but that's not a track, that's a gap between this area and this area. Okay, so in fact there's no space for a track to even go that way. The same up here, these are gaps. I mean, that's a track in between there, you can see. Okay, which goes to here anyway, so nothing goes to there on that side. Therefore, we don't have to worry about that. The other side, well, what I noticed when I unsoldered it is this via came out. You see it? That bit there. And this fits on this way round and solders in here. Now, if we look, is there a track which goes from this pad here I'll just clean this up. So we'll use the fiberglass pen again a bit just to get this clean. I want to see whether or not there are any tracks which go to this pad. On the other side of the board, I can solder it. Okay. And we can say that if there was a via or a collar through there, which there was, if it connects to any internal tracks like power planes, it also connects the same to here. So I don't think, well, A, there isn't anything on this board draws a lot of power, so why would you have big power planes on it? Yeah. So I think as long as we can solder it to here, and we can reassure ourselves it doesn't solder to here. And if it does, if there's a track which goes to here, we can fix that anyway. We can get a bit of wiring through the hole so that track is connected. So if we just check that out and we're happy, then that itself isn't an issue. So what we have then really is the rest of the power supply. Do we check out all the corrosion on this side of it, or do we just try it? And I am very much of the school of we just try it. We don't have a data sheet for this, so it's hard to work out the circuit to some extent. There were no shorts, nothing appears to be blown on the high voltage side of the power supply. So yes, there is some corrosion, but it's less than we had here. I think once again we will take a chance and we will see, does it work or doesn't it? That'll tell us. Of course I had to look, and after a bit of searching, that is kind of like the Dillick roller, but the Dillick roller had a metal base and a metal bar here and the two either side. I never saw this type. They did wider ones and narrow ones on the same unit, so it was sort of like that, but it seems that the name Dillick roller and the original ones have all disappeared, unless you guys know different. I think at this point I'll solder this back in and we'll give this a try. Although there is still some corrosion here and there, I do notice some down by this chip. So this is marked 6600 and then B77J01. To clean that up, you would have to unsolder it and then clean that area of the board, solder it back in again. I don't think you would successfully do it any other way particularly. What we can say though is the power supply is in much better condition than when I first found it. Much better condition. So let's fit this board back on. And let's just try this. We know from the first video, if you've seen it, that it doesn't blow up or blow fuses or anything like that. In fact, if we put the analyzer on and power this up, we can see we only have 5 volt standby. Everything else says low, power good as 0, so it never actually powers up, okay? So we know when it was in that mess, it didn't at least blow fuses. I have this one pad here. We can see it connects to quite a thick track there by the looks of it. Goes off under that way. This is the one where the pad came off the other side and it doesn't connect to anything on this side. I can see inside it, I can see the actual metal sleeve. So I should be able to solder that actually from underneath, but what I think I will do is try to get a bit of solder on this side, get it hot, and then when it's molten, push this through the board. Yeah, and I think that will give us a good connection. That's the theory. I've not actually tried this method before. You could run a very thin bit of wire through the hole and still get the pin through, but that's quite a chunky track, so I'm assuming some current goes down there. If this doesn't work, well, we'll have to try and solder it from the other side, or fit this so it's not quite flush and we can get a tip of a soldering iron in there maybe. Let's see what this does. I mean, it seems like it might work. So we'll get a bit of solder on the pad like that. I'll line the thing up, ready. I'm going to melt that, get it really hot with the soldering iron if I can. I might need some hot air. And then while it's hot, I'm going to push the board through. Yeah, there. It's soldered in. It's soldered in all right. Try and get some focus on that. And from the other side, yeah, I can see solder in there, so I'm confident enough that worked. This is something I accidentally unsoldered, so we need to solder that as well. I do have the board in the correct way round, by the way. Take note. If you have any other suggestions, by the way, how to fix that little problem, I'll be very interested to hear. I'm expecting a few others would as well. So how would you deal with that sort of problem on the repair? Or would you sort of say, thanks Rich, that was a good idea? I hadn't thought of that one before. Just let us know down there. So it's connected up. I have the analyzer attached, so it will start if it's going to start. Mains attached here. This is the little switch for the fan. I've set it to on. I've plugged the fan in, and I have my current limiter up there, the light bulb. Now you might think that that light bulb will stop this going bang, but that is not necessarily the case. It'll just make it stop it blowing fuses. The reason being is because when I power this up, it's going to charge the big capacitors. It's then going to start the standby, which was running before, and then it should start the main supply. If it fails at that point, then these capacitors already have a full charge in them, and they contain a lot of energy. So it's quite capable of blowing up various devices, and then the light bulb will come on. So I guess the only thing I can really do now is just to switch it on, and then let's watch what happens. Yeah. Well, the bulb went on and went dim, but it didn't start, and this is not running. So now, after what I did to it, the standby isn't working either. There's also, because it definitely charged the capacitors, there's going to be some dangerous high voltage in those capacitors now. Okay, and we need to discharge them. So here is my capacitor discharger. Let's just discharge the capacitors. See, 200 odd volts in there. Quite dangerous. Okay, so they are safe. So clearly there was power in here, we can see that. Just waiting for our fingers, but now it's been neutralized. Yeah. So the standby will be this transformer. This is the main transformer, this is the standby. I suspect that is probably the MOSFET that drives that transformer. There's a chip here, but this is on the low voltage side of the circuit, so I'm not totally sure what that's actually doing. It looks like another chip I can't easily identify. .6601. Well, I think that's probably related to the other chip. We can say that much, yeah. 6600, 6601. Sometimes these standby supplies have a self-oscillating circuit, basically made up of a couple of transistors, and usually involving the opto-isolator transistor as well. Can we see where the opto-isolator is on this one? Well, they're on the back actually. So 2 opto-isolators here, okay, a gap cut in the PCB. So we can say, in fact we know, this is the high voltage side of the supply. The 2 transformers, which are, yeah, here, That's the primary of the main transformer. And the other one, somewhere here. Yeah, that's it. It's set a little bit further back. So this is the primary of the standby supply. And it looks like it's probably a self-oscillating one. These are the opto-isolators, exactly where you expected to find them. One of these will be regulating the standby supply, I would imagine, and the other one is probably sending a signal back to this chip to tell it to run, basically, or to control that. So we know where the opto-isolator is. All we have on this side then, capacitor, a resistor, probably a low value current sense, most likely. Can't easily read the markings on it exactly. Sort of green. Depends on which end is the tolerance drive. I can see red, two other things, okay. This I'm pretty confident will be the switching MOSFET for that. There's a diode down there, probably snubber or back EMF diode probably. And then on the other side, there's no controller IC. So this is going to be a self-oscillating circuit made up of, I see 2 transistors or possibly diodes. There's a diode there. The opto-isolator, as I said, would be involved in that circuit. Considering the standby was working before I had all this in the sink and cleaned it all up, makes me think there's probably no faulty components here. It's more likely that something is corroded through somewhere. I'll check the diodes, I'll check the transistors, see how they look in circuit. You can see these are glued down, so they're not particularly easy to work on. We have some high value resistors in series here, so 3 with 0, 0 and 4 more zeros, 3 meg. 3 meg. That one, 2.2 meg. This will be, I would think, the startup supply for this. It probably then has a supply coming back from an auxiliary winding on the transformer. Looks like we have probably a primary and an aux winding, which then keeps us running. If I don't see a problem there, well, look at that resistor on the other side. But other than that, it's going to be a case of like, well, should we? Because I'm not totally sure I'd ever trust this thing if I get it working. This was always more of a case of, can we actually fix something like this for the sake of it, really? Let's have a look. I'm just wondering why the standby would be working and now isn't. I mean, it's possible there's a short on this board, which is powered initially from there at least. We can have a look at that maybe. So, diodes. Looks like a diode. Okay. Reads very low actually, that. Reads more normal. I'm assuming, yeah, probably is a diode. Reads open. Open, let's go for a PMP. Yeah, I see a junction. See a junction there. So PMP positive to the emitter should read open, you would think. Yeah. Another one. Possibly another PMP transistor. Yeah, I see the junction. See the junction. Again, put the positive to the emitter. Yeah, then it goes up, so capacitor was charging, okay. This one. Looks like an NPN, so positive to the collector. Reads open. Zener diode or diode? Wrong way. Reads like a diode once the capacitor is charged. Another one. Reads like a diode once the capacitor is charged. I'm not sure about this bench multimeter that bleeps continually on diode junctions. Interesting what you guys think, yeah. I think I can probably set the threshold a bit lower so it only bleeps on shorts. In fact, I could do that actually. Why not? I've set the threshold down to 0.2, so it would only bleep now on shorts or Schottky diodes, yeah. So we can see we still have a very low reading there. But now the diodes don't bleep. I think that's better for you guys, let me know, yeah. The MOSFET, I'm sure it will be a MOSFET, is here. I can see the 3 pins. So this end is going to be the gate or base. Let's see. Capacitor charging goes high or high-ish. That looks more like a transistor junction. Yeah, that's just going high. That's probably what we're seeing there, is a resistor between the gate and source, I would think. If we go to resistance range, let's have a look. Yeah, and 3.3k, which would be a standard. No, it's gone to 1.9 meg high actually. Okay, interesting. I can unsolder that, but I think that's probably okay. I'm a bit concerned, much more so, by what I see across this one. I'm in resistance range. Oh, 270 ohms. Now that is a standard resistor value, which makes me think what we have here is a diode in parallel with a resistor. 270 ohms. I mean, these are low value, 2.2 ohms. I don't see exactly where it is, but I can see that goes to there. Not sure where this end goes, okay. It doesn't go here, I'm sure, because this would read much slower. Yeah, you see 2.3 ohms, okay. So, no, I'm not suspicious about that now. So when you get these things, guys, go to resistance range and have a look, and if you see something like that, which is like a standard value resistance and a fairly low one across the device, that will explain why you're reading a low reading in diode mode, okay? So I would question the power device, but I'll be surprised because, as I say, the standby was working and all I've done is clean the board. Can we see where the output of the standby is? Yeah, we can. In fact, there's likely to be 2 outputs. So you'll have a 5 volt. This could be a voltage regulator here. And you'll probably have another secondary voltage which powers some of this circuitry. On an ATX, usually it's somewhere between 16 to 22 volts, something like that. There's 2 capacitors here. Are they in parallel? They're here, so one's here and one's here. Okay. Yes, looks a bit like a dry joint, but I'm not convinced it is. Let's have a look what's across the capacitor. Quite a high resistance. Well, no, 100 ohms. That looks reasonable, you know, for a load on standby. That one just reads open. Okay. So I don't think there's any shorts on the output of this. I mean, it's obviously just a quick test, but I don't think there are. Let's get this out, and let's get this resistor out as well, because I can't really see what that actually is. And let's just measure there, okay. And we can probably test this diode down here as well at the same time. Well, I managed to get the MOSFET out. It's still attached to the heatsink, actually. I unsoldered the 3 pins with the vacuum desoldering tool, but this one I couldn't, so I got a blob of solder back on there. I was holding this in my long nose pliers, heated this up and just pulled this out. It came out fairly easily. Let's have a look at it. So it's marked CEF02N7. This looks and sounds like a MOSFET to me. That sort of numbering. Okay. Yeah, it's good. MOSFET. So that's all right. The components on the other side either test okay or we can explain the readings we have. And I think we can also explain why this is not working, at least at the moment. So, corrosion down here. This is behind the MOSFET. It's nothing to do with where I unsoldered it. This was the heatsink. These are the 3 pins. But we can see this is got rot in it here. And then, you see this track? One end there. Other end here. Yes, that kind of goes to there. I don't think, I could be wrong, wouldn't be the first time. I think this is just rotted through. I don't think it's like blown open circuit due to some sort of fault. And this happened after I cleaned the board, so more than likely this was just hanging on, yeah. And now it isn't. That doesn't go to the power resistor, it kind of goes off down that way. To fix that and to check the rest of this out, because I can see more of this now down here, yeah, you see where it's going. We would have to unsolder the transformer so we can really get in here. Okay. It's under the edge of there as well, you see. So, right. This is, to be frank with you, if I or we think it's worthwhile, another job, another video. I would say that we need to get the transformer out, possibly both of them. We need to get this heatsink out with all the associated components. Then we can check things like this resistor. This capacitor is probably one that charges up from the high value resistors on the other side that gives the initial power to get this going. So check that. Yeah, and just in this whole area, and we may have a chance to get that working. Yeah, this is that other area. I'm closer up now so you can get a better look at that. So there's that lot as well. And to be quite honest, there's more of it down under here. But to get to that, I think you're going to have to take this board off, and I don't think that's going to be easy. Guys, epic, yeah, what do you think? So, down there, let me know. Would you do that? And would you feel you could trust this anyway if you did? I suppose at least without this in the way I can get onto that bit as well. Would you not do that? Or would you actually say, Rich, actually, no, I think you've done enough there. We will see, yeah. Okay, down there, let's talk about it. Hope you did enjoy that. I think we had a bit of fun there and looked at some different techniques of measuring components in the circuit. So I think you probably have learned something here, if it's only to leave this sort of thing alone. Okay, down there, guys, let's chat. I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.